Right now, somewhere in the world, someone is cooking rice. Not as a special occasion, not because they thought carefully about it, just because it's dinner time and that's what dinner is. In a student flat in Tokyo, in a village in Nigeria, in a restaurant in Sao Paulo, in a house in California, in millions of places simultaneously, water is being brought to a boil and rice is being added to it, and that is perfectly ordinary. Half of all the people on Earth eat rice as their primary source of calories every single day. That's extraordinary. Half of humanity every day, one grain. And yet, if you grow up in a culture where rice is a side dish, an optional accompaniment, something that comes alongside the main event, it is quite easy to go your whole life without ever really thinking about it, without noticing how extraordinary it is, without knowing that the thing you're rinsing in the sink before you stick it in the pan is probably the most consequential plant in human history. Because rice didn't just feed civilizations, it built them, it shaped how land was engineered, how societies were organized, how wealth was measured, how wars were fought, how art was made, and how the genetic inheritance of millions of people has developed over thousands of years. And there are a few things about rice that most people don't know, and which I find astonishing. Wild rice, the thing in the expensive packet in the supermarket that you mix into salads, is not rice. There are over 40,000 varieties of actual rice, and they're so different from each other that calling them all the same food is a bit like calling a chimpanzee and a human the same creature. Cooked rice left out at room temperature for too long can make you seriously ill, and reheating it doesn't fix this. A man from Iowa developed crop varieties that are estimated to have saved 1 billion lives, and most people have never heard his name. And scientists have engineered a rice that glows gold, literally the color of a sunset that could prevent childhood blindness. And it has spent 25 years trapped in a controversy that has nothing to do with whether it works. I'm Alexandra. Welcome to the Hidden Life of Things, everyday history for anyone who's ever looked at something ordinary and wondered, how did this actually get here? Before we go anywhere, I want to clear up the wild rice thing because I think it's one of the most satisfying small myths to debunk in food history. Wild rice, the dark, nutty, chewy grain that comes in expensive pouches and gets added to salads and pilafs to make them look more interesting, is not actually rice. It's not even distantly related to rice. It's a completely different plant genus called Zizania, native to the Great Lakes region of North America. It is more closely related to oats than to rice. The Ojibwe people of the Great Lakes called it manomin, and it was central to their culture and diet. European colonists called it wild rice because it grew in water and the seeds looked vaguely familiar. The name stuck. It is genuinely delicious grain with a fascinating history of its own, but it is not rice. Actual rice is Oryza sativa, Asian rice, and Oryza glaberrima, African rice. And within just the Asian species, there are estimated to be over 40,000 distinct varieties in cultivation or preservation systems worldwide. 40,000! Think about what that number means. The word rice covers an almost incomprehensible diversity. Long-grain jasmine rice from Thailand with its floral fragrance that fills the kitchen when it cooks. Short-grain sushi rice from Japan, which goes sticky and glossy and holds its shape when pressed. Basmati rice from the Himalayan foothills with its distinctive nutty aroma and the way each grain stays separate. Black rice, sometimes called forbidden rice in China because it was historically preserved for the emperor, with its deep purple color caused by the same anthocyanin antioxidants found in blueberries. Red rice from Bhutan and West Africa, glutinous rice, sometimes called sticky rice, which becomes almost paste-like when cooked and is used in Southeast Asian desserts and ceremonial foods. These are not variations on a theme. They are, in many cases, as different from each other as a baguette is from a sourdough. Same basic material, completely different character. The grain we call rice is not one thing. It is an entire biological world, shaped over thousands of years by human beings selecting for specific qualities, flavor, texture, aroma, cooking behavior, growing conditions, yield, in thousands of different environments. And when I think about plants that survive in difficult environments, that adapt, that find a way to hold their ground in conditions that would defeat something softer, I keep coming back to one that has nothing to do with rice at all. It doesn't grow in paddies, it doesn't feed half the world. It grows in the kind of landscape where the wind comes in sideways and the ground doesn't give easily. The thistle, spiky, stubborn, improbable, choosing the difficult ground and holding it without making any fuss about the fact that it does. There is something in that persistence that I find quietly beautiful, the kind of courage that doesn't announce itself. The story of where rice came from is, like most things about rice, bigger than the version most people have heard. The standard story locates the origin of rice in China, and that's broadly right, but it's not the whole picture. Modern genetics and archaeology suggests that Asian rice, or Rhiza sativa, was first domesticated in the Yangtze River basin in China somewhere between 8,000 and 13,000 years ago. That's a wide range because domestication wasn't a single event. It was a process. Humans living in the region were harvesting wild grasses, replanting them, selecting seeds from plants with qualities they found useful, larger grains that stayed on the stalk instead of scattering when we touched them, plants that matured predictably, generation by generation over thousands of years. They were shaping the plant into something different from its wild ancestor. But here is the fact that I think changes the whole picture of rice history. While this was happening in China independently, completely separately, without any contact between the two developments, West African societies were domesticating their own rice species. Oryza glaberrima, African rice, was developed probably around 3,000 years ago. Different species, different continent, same idea. Humans in two completely separate parts of the world facing similar challenges of food production, independently arrived at rice as a solution. Rice is not one invention, it is at least two. And that parallel development tells you something important. Rice wasn't discovered like gold or oil. It was created, shaped by human hands and human intelligence, slowly and carefully over millennia. The rice in your kitchen is a product of thousands of years of agricultural science conducted by people who had no formal education, but who understood their plants with a depth and precision that specialists today are still working to fully comprehend. Here is the thing about rice that is rarely said clearly enough. Rice farming is hard in a very specific way. It requires coordination. A rice paddy is not an isolated plot of land. It is part of a water system. Water must be brought to the field, distributed across it evenly, controlled so that the plants get the right amount at the right time, and then drained. In the mountainous terrain where much of the world's traditional rice farming happens, this means building terraces, flat stepped fields cut into hillsides with channels running water from terrace to terrace in a precisely managed flow. The rice terraces of the Philippine Cordillera, built by the Ifugao people over roughly 2,000 years ago and covering about 10,000 square kilometers of mountain, are sometimes called the eighth wonder of the world. They're still farmed today. They're also, when you understand what they represent, the amount of collective human labor, planning and engineering over 2 millennia, among the most extraordinary things humans have ever built. And water systems don't work if only one farmer manages them. They require agreement, maintenance, collective decision-making. The farmer at the top of the channel can't simply divert all the water. The farmer at the bottom has rights too. Traditional rice farming communities developed sophisticated social structures, codes for water allocation, dispute resolution, collective labor for maintenance that predate most of the formal legal and governance systems we associate with civilization. Historians have argued that rice farming may have been one of the drivers of collectivist social values in East and Southeast Asian cultures. The emphasis on community, on interdependence, on collective responsibility, because rice farming made those values not just admirable, but practically necessary. You couldn't grow rice successfully alone, you needed your neighbors. And when rice farming worked well, when the water came and the harvest was good, it was extraordinarily productive. Rice yields more calories per hectare than most other staple crops. It supported population densities that other agricultural systems couldn't sustain. It made possible the large, stable societies that we think of as the great civilizations of Asia. Rice didn't just feed those civilizations, it made them possible. In feudal Japan, wealth was not measured in gold, it was measured in rice, specifically in a unit called the koku. The amount of rice considered sufficient to feed one person for 1 year, roughly 180 liters. A samurai's salary was paid in rice. A feudal lord's power was measured by how many koku his domain produced annually. Oda Nobunaga, Toyotomi Hideyoshi, Tokugawa Ieyasu, the three great unifiers of Japan in the 16th and 17th centuries, were all, in the most literal economic sense, rice lords. Their wealth and power were expressed in grain. Rice warehouses called kuragura became economic centers. Receipts for stored rice became tradable documents. Osaka, Japan's great commercial city, developed something that historians describe as early futures trading in the 17th century, where merchants bought and sold contracts for rice that hadn't been harvested yet, setting prices for rice that would arrive in months. This is one of the earliest documented examples of futures markets in the world history. The world's first commodity futures exchange may have been built around rice. In other parts of Asia, taxes were collected in rice rather than money. Imperial granaries held the stored wealth of states. Control of rice supply was control of population. When harvests failed, when drought or flood destroyed the crop, the consequences were not just hunger, but political instability, unrest, sometimes the collapse of dynasties. In ancient China, there is a pattern repeated through multiple dynasties. Bad harvests lead to popular uprisings, lead to regime change. The mandate of heaven, the Chinese philosophical concept that the emperor ruled by divine approval, was in practical terms at least partly an agricultural concept. An emperor whose people were starved was clearly losing the mandate. The legitimacy of power was connected to the fertility of the fields. Rice was not merely agriculture, it was infrastructure, it was politics, it was power. There is a chapter of rice history that I want to name clearly because it is important and often not included in the casual telling of the grain's story. Rice cultivation in the Carolina Low Country, what is now South Carolina and Georgia in the United States, became one of the most profitable agricultural enterprises in the colonial Atlantic world. By the early 18th century, Carolina rice was being exported across the Atlantic in significant quantities, making the plantation owners of the region extraordinarily wealthy. That wealth was built on a knowledge system that came from West Africa. Many of the enslaved people transported to the Carolinas came specifically from the rice-growing regions of West Africa. The area historians sometimes call the Rice Coast, corresponding roughly to modern-day Sierra Leone, Senegal, and Gambia. These were people who came from societies with centuries of expertise in wet rice cultivation, in building paddies, managing tidal irrigation, processing grain. Their agricultural knowledge was not incidental to the Carolina rice economy. It was foundational to it. European planters did not know how to grow rice in the low country environment. The enslaved people they bought did. The specific techniques of tidal irrigation that made Carolina rice farming work, engineering the movement of tidal waters in and out of the fields to flood and drain them, were techniques developed in West Africa and brought across the Atlantic in the minds of people who were being treated as property. Modern scholarship has increasingly recognized this as a major transfer of agricultural knowledge that built significant wealth for a small class of plantation owners, while the people whose knowledge it was lived in conditions of brutal exploitation and violence. The history of rice in the Americas is in part a history of stolen knowledge, of agricultural science developed over generations in West Africa by communities who received none of the returns from its application in the New World. This is part of the rice story as well. I promised you something practical and slightly alarming, and here it is. Cooked rice can make you seriously ill, and reheating it doesn't fix the problem. I want to explain why, because I think most people have a vague awareness that there's something about rice and food safety without knowing the actual mechanism, and the mechanism is interesting. Uncooked rice grains can contain spores of a bacterium called Bacillus cereus. These spores are robust. They survive normal cooking temperatures. So when you cook rice, you kill most bacteria, but the cereal spores survive. If the rice is then left at room temperature, those spores germinate and the bacteria start multiplying. And here is the critical point. As they multiply, they produce toxins, heat-stable toxins, toxins that remain active even if you then reheat the rice. So the scenario goes like this. You cook a big batch of rice, you eat some. You leave the rest on the counter to cool down while you do other things. A few hours pass. The bacteria multiply. Toxins are produced. You put the rice in the fridge. The next day, you reheat it thoroughly, you eat it, and you get ill. Because the toxins are still there, thoroughly reheated, completely unaffected by the temperature. The illness is called fried rice syndrome, named because it was first widely documented in Chinese restaurants where large batches of rice were cooked, left out for service, and then used in fried rice the next day. The symptoms include nausea, vomiting, and stomach cramps. Usually it resolves within 24 hours. In rare cases, in vulnerable people, it can be more serious. The fix is simple but specific. Cool cooked rice quickly, ideally within an hour, and refrigerate it promptly. Don't leave it sitting on the counter. Don't keep it in the fridge for more than a day or two. And don't put it in a rice cooker on the warm setting for hours, which is a very common practice that creates exactly the conditions the cereals bacteria loves. A lot of people know you're not supposed to reheat rice, but the reason isn't the reheating, it's what happened before you reheated it. The cooling and storage is where the problem occurs. While we're in the territory of things about rice that nobody tells you, there is one more. And this is one I want to handle carefully because the numbers sound alarming at first, and I want to give you the full picture. Rice contains arsenic, not because of contamination or a modern agricultural problem specifically, though farming practices do affect levels, but because rice is unusually efficient at absorbing arsenic from soil and water as it grows. It's the nature of the plant. Arsenic occurs naturally in soil and groundwater, and rice, grown in flooded paddies with roots constantly submerged in water, absorbs significantly more of it than most other crops. Brown rice contains more arsenic than white rice. This is because arsenic concentrates in the outer bran layer, the part that's removed when brown rice is milled into white rice. So the healthier choice in most other respects contains more of the thing we'd rather have lesser. That's an uncomfortable nutritional trade-off, and it's worth knowing it exists. Now, the important question is not whether rice contains arsenic. It does. The question is what that actually means for people who eat it regularly and what you can do about it. If you cook rice the way you'd cook pasta in a large excess of water and then drain it off at the end rather than letting it absorb, you can remove roughly 40 to 60% of the arsenic, depending on the ratio of water to rice. At 6 parts water to 1 part rice, you get about a 40% reduction. At 10 parts water to 1 part rice, closer to 60% reduction. This is the opposite of how most people cook rice and the opposite of what rice cookers do. A rice cooker cooks rice by absorption. The water goes into the grain, nothing is drained off, which means any arsenic in the water stays in the rice. Boiling in excess water and draining moves it out. Now, the trade-off. If you're cooking white rice this way, you're also washing away the B vitamins and iron that have been sprayed onto the surface of enriched white rice during manufacturing. This is why cooking instructions for white rice specifically say don't rinse, use minimal water. They're protecting those added nutrients from washing away. Boiling and draining defeats that purpose entirely for white rice. Brown rice, however, is different. Its nutrients are inside the grain, not sprayed on the surface. Boiling brown rice in a large excess of water and draining reduces arsenic by close to 60%, but only reduces iron content by about 5%. The vitamin content drops by roughly half, which is a real loss, but the core mineral content holds up significantly better than white rice does under the same treatment. What this means practically: if you eat rice occasionally, this probably isn't something you need to change how you cook. The risk from occasional consumption is low. If you eat rice every single day as a primary staple, and billions of people do, it's worth knowing that boiling in excess water and draining, particularly with brown rice, meaningfully reduces your arsenic exposure without destroying the nutritional value of the grain. The populations who have eaten rice as a daily staple for thousands of years in South and East Asia, across Africa and the Americas, have not experienced systemic arsenic poisoning as a consequence. The levels in rice, while higher than in most other grains, are not at the levels of acute toxicity. The concern is about cumulative, long-term exposure in high consumers, and the research suggests that adjusting your cooking method is a meaningful lever if you're in that category. Rice is still one of the most important foods in human history. This is just one more thing to know about it. Here's the name you should know: Norman Borlaug. In the 1940s, Borlaug went to Mexico to work on improving wheat yields. He developed new varieties of wheat that were shorter, the stem didn't grow so tall that the heavy seed head made the plant fall over, higher yielding, and disease resistant. The results were extraordinary. Mexico, which had been importing wheat, became a wheat exporter within a decade. When these varieties were introduced to South Asia in the mid-1960s, to India and Pakistan, which were facing the prospect of catastrophic famine, wheat yields doubled and then tripled. The predicted mass starvation did not happen. Borlaug won the Nobel Peace Prize in 1970. But the Green Revolution was not only about wheat. Borlaug's approach, developing high-yield, disease-resistant crop varieties suited to intensive cultivation, was applied to rice by researchers at the International Rice Research Institute in the Philippines. In 1966, they released a variety called R8. It yielded roughly 10 times more grain per plant than traditional varieties under optimal conditions. R8 was not perfect. It required significant fertilizer and water inputs. It had a texture that many traditional rice cultures found less appealing than their own varieties. And the Green Revolution more broadly, the shift towards intensive input-heavy agriculture, brought environmental costs that we're still reckoning with. Soil degradation, water depletion, loss of agricultural biodiversity, dependence on chemical inputs. But the counterfactual, what would have happened to the hundreds of millions of people facing food shortages in the 1960s and 1970s without those high-yielding varieties, is sobering. Borlaug himself was not a simple hero, and the Green Revolution was not a simple triumph. It was a complicated intervention that prevented an enormous amount of suffering, while also creating new problems. The person who may have done more than anyone in history to prevent human death from starvation was a plant scientist from Iowa who spent his career in fields in Mexico and South Asia doing painstaking work that got essentially no public attention for most of his life. He died in 2009. Most people have never heard of him. And now I want to tell you about the most controversial version of rice that has ever existed, a rice that looks like something out of a fairy tale, and whose story, 25 years long and still unfinished, tells you something important about science, politics, and the gap between a good idea and the world's willingness to accept it. It is called golden rice, and it is, quite literally, golden, a warm, deep yellow, almost orange, the color of a sunset or a field of wheat. Not because of any dye or coating, because of what's inside of it. Here is the problem it was designed to solve. Vitamin A deficiency is one of the most widespread nutritional deficiencies on Earth. An estimated 250 million preschool children are affected. It causes night blindness and, in severe cases, complete blindness, and it kills. Children who are severely vitamin A deficient have weakened immune systems and are far more vulnerable to common infections. The World Health Organization estimates that vitamin A deficiency contributes to hundreds of thousands of child deaths every year, particularly in South and Southeast Asia and Sub-Saharan Africa. Now, here's the cruel irony. The populations most affected are often the ones who eat the most rice, and rice, ordinary white rice, contains almost no vitamin A, or more precisely, it contains no beta-carotene, which is the compound the body converts into vitamin A. Beta-carotene is what makes carrots orange, what makes sweet potatoes orange, what makes pumpkins orange. Rice, which can make up 80% of the daily diet in some of the poorest parts of Asia, contains none of it. Two scientists, Ingo Botrykus at the Swiss Federal Institute of Technology and Peter Bayer at the University of Freiburg in Germany, started working on this problem in 1982. Their idea was to genetically engineer rice to produce beta-carotene in its grain, not in the husk, not in the leaves, in the part you eat. the white endosperm, the bit in the middle. In 1999, they succeeded. They took genes from daffodils and from a common soil bacterium and inserted them into rice DNA. The result produced beta-carotene. The rice turned golden. In the year 2000, they published their results in the journal Science and appeared on the cover of Time magazine under the headline, "This rice could save 1 million kids a year." The scientific community was excited. The humanitarian case was compelling. The funding came from the Rockefeller Foundation. The technology was licensed to Syngenta, a major agricultural company, but with a crucial condition built in. Farmers in developing countries earning less than $10,000 a year could have it for free. This was not designed to make money. It was designed to prevent blindness. And then it got complicated. The first version of golden rice had a problem. The beta-carotene levels were too low. You would have had to eat an impractical amount of it to meet your daily vitamin A needs. Critics, and there were many, seized on this. A new version called GR2 was developed using genes from maize rather than daffodils, and this version contained dramatically higher levels of beta-carotene. According to the International Rice Research Institute, about a cup of this rice per day could provide roughly 50% of an adult's recommended daily vitamin A intake. Human studies confirm that the body can convert the beta-carotene in golden rice into vitamin A effectively. But by this point, the controversy had taken on a life of its own. Opposition to golden rice became one of the most intense flashpoints in the broader GMO debate. Greenpeace campaigned actively against it. In 2013, protesters in the Philippines physically destroyed a field trial of golden rice, tearing the plants from the ground before the trial could be completed. Scientists and public health advocates were furious. Over 100 Nobel laureates signed an open letter criticizing Greenpeace's campaign against golden rice specifically, calling the opposition a crime against humanity, given the scale of vitamin A deficiency. The arguments against golden rice were several. Some said that GMO crops carry unknown risks. Some argued that the real problem is poverty and food diversity, not a missing gene in rice, that the solution should be better diets, not engineering staple crops. Some pointed out that golden rice had been a development for decades and still wasn't deployed at scale, suggesting it might not be the practical solution its advocates claimed. The arguments in favor were equally direct. Children are going blind from a deficiency that a cup of rice per day could address. The rice requires no different farming methods than ordinary rice. It poses no demonstrated health risks. The delay, caused substantially by regulatory battles and activist opposition, has real human costs. The Philippines became the first country to approve golden rice for commercial cultivation in 2021. Bangladesh and other countries have been in regulatory review. As of now, golden rice is still not being eaten at scale by the populations it was designed to help. After more than 40 years of research and 25 years of controversy, the story is still unfinished. I'm not going to tell you what to think about GMOs. That's a bigger conversation than one podcast episode can hold. But I want you to know that this grain exists, that it was made with genuinely humanitarian intent, that the science behind it is solid, and that the gap between a good scientific solution and that solution actually reaching the people who need it can be vast. Shaped by politics, by fear, by institutional inertia, by legitimate questions about power and control in the global food system. The cultural life of rice extends far beyond the plate. In South India, particularly in Tamil Nadu, women create intricate geometric floor patterns using rice flour, a practice called kolam. These patterns are made at the threshold of the home, typically at dawn, as part of a daily ritual. They are beautiful, mathematically sophisticated. Some kolam patterns encode fractal geometry and deliberately temporary. They are walked across, erased by the day, and remade the next morning. The impermanence is the point. The making matters as much as the made thing. In Japan, sushi, the most globally recognized Japanese food, is actually a rice dish. The fish is not the point, the rice is. Sushi rice is seasoned with a precise mixture of rice vinegar, sugar, and salt. It must be cooked to exactly the right texture, firm but not hard, with enough starch released to hold together when pressed. The temperature matters. A skilled sushi chef's relationship with their rice is the foundation of their craft. The fish is secondary, the rice is primary. The history of sushi itself is, in its origin, a story about preservation rather than luxury. The earliest forms, nare sushi, involved fermenting fish with rice for months, sometimes years. The rice was used not to be eaten, but to ferment the fish and was then discarded. Modern sushi, the fresh rice, fresh fish combination we recognize, is a relatively recent development, popularized in the Edo period of Japan, which is 1603 to 1868, as a street food. It went from a preservation method to a culinary art form in the space of a few centuries. Rice paper used in East Asian calligraphy and brush painting is not actually made from rice. It's typically made from the pith of a plant called the rice paper plant, or from bamboo or other plant fibers. But the confusion is instructive. The material so essential to East Asian artistic traditions became associated with rice even when rice wasn't the ingredient. Rice is so foundational to these cultures that it became a default assumption. Rice straw, the stalks left after the grain is harvested, became roofing material, rope, baskets, floor mats, sandals, animal bedding. Rice husks, the outer shell removed during milling, were used as fuel, as insulation, as the base for traditional mortar. Modern industry uses them to produce industrial silica, water filtration materials, and biodegradable plastics. The rice plant in cultures that grew up with it was used in its entirety. Not a part of it was wasted. I want to spend a moment on something that I think is underappreciated, the extraordinary diversity of what humans have done with rice in the kitchen. Because the word rice covers not just 40,000 varieties of grain, it covers an almost incomprehensible range of cooking methods, textures, forms, and traditions. The same grain becomes completely unrecognizable across different kitchens. In Japan, the short grain rice used for everyday eating is cooked by absorption, a precise ratio of water to grain brought to a boil, then covered and steamed until every drop of water is gone. The result is slightly sticky, glossy individual grains that clump just enough to be picked up with chopsticks. The Japanese rice cooker was invented specifically to perfect this process, and a high-end Japanese rice cooker will adjust pressure, temperature, and timing based on the season, the humidity, and even the age of the rice. This is not excess. This is a culture where the quality of the rice is as important as the quality of anything else on the table. In India, the same concept of absorption cooking is used for basmati, but the goal is the opposite. Each grain must stay completely separate, elongated, dry. Basmati is often soaked first, then cooked in precisely salted water, sometimes with whole spices, cardamom, cloves, a bay leaf that perfume the grain without overwhelming it. The rice for biryani is deliberately par-cooked, then layered with meat and sealed and steamed in a vessel with a lid sealed with dough, a method called dum, so that the grains finish cooking in the steam of the spiced meat below. The result is rice that has absorbed flavor from beneath while remaining light and separate above. In West Africa, rice is often cooked in a single pot with meat, vegetables, and spices. Jollof rice, the deeply spiced tomato red one-pot dish that is the subject of an ongoing and very serious debate between Nigeria, Ghana, and Senegal about who makes it best, is cooked in a way that deliberately allows the bottom layer to catch and caramelize. That slightly scorched, intensely flavored crust at the bottom is not a mistake, it is the price. In Iran, the same crust at the bottom of a pot of rice is called tahdig, and it is so beloved that special pots are designed to produce it. The word translates as bottom of the pot. It is, in many households, the most fought-over part of the meal. In Spain, paella, the iconic rice dish of Valencia, is cooked in a wide, flat pan specifically designed to maximize surface area. The rice is not stirred once it goes in. It cooks in a thin, even layer, absorbing the stock from below, and the bottom develops deliberately a crust called socarat. The crust is the sign of a paella cooked correctly. Again, the scorched bottom is the goal, not the mistake. In Italy, risotto takes the same grain, short grain arborio, carnaroli, or violone nano rice, and does something completely different. The rice is cooked by ladle. Stock is added gradually, one ladle at a time, and the rice is stirred continuously. The stirring releases starch from the outside of the grains into the liquid, creating a thick, creamy, almost saucy consistency that holds the grains in suspension. The finished risotto should flow like lava when you tip the plate, a consistency Italians call all'onda, meaning in waves. It takes 18 minutes of continuous attention and constant stirring. It cannot be rushed. It cannot be left alone. And then there is congee or juk or kayu or chao, depending on which part of Asia you're in, where rice is cooked in a huge excess of water for a very long time, until the grains completely break down into a thick, silky, almost porridge-like consistency. It is the comfort food of much of Asia. It is what you eat when you are ill. It is what a bowl of soup is in the West. A plain congee topped with a soft-boiled egg and a drizzle of sesame oil is in the right context one of the most deeply satisfying things a human can eat. Rice flour becomes noodles, rice vermicelli, flat rice noodles, the noodles of pad thai and pho and laksa. Rice is fermented to make sake in Japan, soju in Korea, rice wine across Southeast Asia. Rice is puffed and formed into crackers and cakes. It is ground and used to make dosa and idli, the fermented rice and lentil pancakes and dumplings of South India. It is soaked and ground and mixed with coconut milk and steamed in banana leaves. It is made into flour for mochi, the sticky Japanese cakes that are soft and chewy and eaten at New Year. The point I'm making is this. Rice is not one food. It is not even dozens of food. It is the starting point for an almost infinite variety of textures, flavors, preparations, and traditions. Each one the product of a specific culture's centuries-long conversation with a single grain. The rice on your shelf is already a world. What you do with it is another world entirely. So the next time you cook rice, whatever kind, however you cook it, just take 1 second. You're cooking a grass that humans began domesticating 10,000 years ago in the Yangtze River Basin, a plant shaped over generations where agricultural intelligence was still trying to fully understand. A grain that built terraces into mountainsides across Asia, funded samurai, organized societies, fueled a revolution in food production that prevented starvation on a scale almost too large to imagine. A grain that scientists made golden to try to prevent childhood blindness, and that is still waiting for the world to let it do its job. The thing that looks like a background ingredient, the simple, unremarkable, slightly boring side dish, is the plant that half of humanity depends on every day. The most consequential crop in human history, an entire world of 40,000 varieties, each one shaped by a specific place and a specific community's relationship with that place over centuries. And also, put it in the fridge quickly after you cook it. History isn't only in museums. Sometimes it's in the pot on your hob, and it has been feeding humanity for longer than most of what we think of as civilization. If this episode made you see the rice in your kitchen differently, if it made you want to try a variety you've never cooked before, or think about the paddy fields that the grain in front of you came from, that's always the point. The Hidden Life of Things is on Spotify, Apple Podcasts, and wherever you listen. A follow or a like genuinely helps, and if someone in your life thinks rice is boring, maybe send this to them. And here's your clue for next time. It sits on your desk right now, or in a drawer, or at the bottom of a bag. It's the first thing a child learns to hold, and the last thing a writer puts down. For centuries, it was considered a luxury only the powerful could afford. When an empire tried to tax it, a monk revolutionized it, and a country turned it into an art form so precise that a wrong angle, a wrong pressure, a wrong material can ruin everything. It marks, it communicates, it leaves a trace of you behind. What is it? Stay curious. I'm Alexandra, and I'll talk to you next week.